Hello, this is Adrien Niodusawa, and I welcome you to this third part of the Introduction to Programming course. In the previous 2 weeks, we have looked through all these up to like 12, actually 10. Yeah, we have looked through the basics of installing Python, getting started, variables and data types, basic operation, taking inputs from user. We saw about strings and REST, and we learned some string method and REST methods. And we touched the control flow, if and else, and we also used the else if statements inside those two. And that's basically what we did in the previous two sections. And in this third section, we do a quick recap on the control flow. And then we look at the for loops, and we'll also look at the while loop, and we look at the functions. And as a bonus for today, we will actually go ahead and try to solve some practice exercises. So the really key goal of this third part is for you to be able to write the reusable Python functions to perform specific tasks. And without further hesitation, I will go ahead and start the third week content. So a quick recap. In the previous session, we saw that to write our control flow statements, we can use if keyword. So basically, it's an if statement, but we write an if keyword, and then we write some condition here. We write the semicolon, and we hit enter, which will automatically give us a perfect indentation if you're using Python idle. Otherwise, you can set by default, by default Python uses 4 spaces for indentation. And then you will write your logic inside this block, and outside that block is where you will come back to write now what happened. The elif statement, you will write it here, and then you write the corresponding logic. You come outside again, you write another elif, you write the logic. Notice that you can write as many elif statements as you want. You can write as many alternatives as you want, and when everything fails, then this is where your elif statement comes in handy. And this is basically what will get executed if all those things fail. Now this is a quick example. Notice that you can also nest the if statements. For example, if you want to check password and the username, you may say, okay, I will first check the username if it's Bob, and if the username is Bob, then only then will I go ahead and check the password, because if a person is trying to access maybe the door or a platform and the username is wrong, you could write your logic in such a way that you don't even need to check their password. Because if the name is not Bob, we will not bother going here inside this whole block. Instead, we will jump to this else statement. On the contrary, if the name was correct, then we go inside and want to check their password as well. So we check if the password is correct. If it's correct, we can give them a login successful, otherwise we can give them. If it's wrong at this point, notice that the problem is the wrong password. So we can actually be specific. At this point in Ethereum, your password is wrong. Because to be able to get inside this block, their name should have been correct. And the password was wrong. Now, if we jumped this part, it means the name was not correct from the first place. We can tell them the username is wrong. And this is basically running behind so many platforms. Just remember, indentation is very important in Python. The logic which are on the same block should be on the same indentation level, which are these lines I've drawn here. And this is what you need to be really careful with Python. Now for the cool part of today, the for loop. So the core idea of the for loop is, imagine you had a list of scores for the students. For example, you have all these scores from your students, and all of a sudden you realize that you need to add 5 marks for every student, and your scores are stored in a list. One way you could do it, which I call the ugly way, is to grab every student's score and manually add 5 marks on that score. And that will work. The problem with that is you will have to write, if you have a class of 50 students, you will have to write those 50 statements, changing everything manually. And should you mess up somewhere, then something will go wrong. Now, you see, you will notice that this is a very repeating logic. It's a very repetitive logic. We are doing the same thing. So you will ask yourself, is there no better way in which I can say, okay, I have this list of student scores, Now I want to write a small piece of logic that will sound something like this. For every score in my list, take that score and add 5 to it. That's basically what I want to do. So that intuition there, that idea is what the for loop help us to do. We go through elements and we do something on those elements. And that idea of going through elements is what we'll be referring to as iterating through elements from now on. So a better way to do it, which I will not explain in detail this slide, but on the next one, is to say, okay, I will go through the scores, and for every score I will add 5. And don't worry too much if you don't understand it at this point, because that we're going to run about it on the next slide. But basically, notice that here we use 2 lines of code, and it doesn't matter how large the inputs become, these 2 lines of code will still do the same job as they were doing for a small. First, it take a little bit more time, but notice that it's just 2 lines of code. If it's a million inputs, it will still do the same job being 2 lines of code. Where here you would have to write 1 million lines of code. And having a few lines of code means it's much less prone to error. So if you're writing too much, you're more likely to make errors. Now the way we write for loops, the easiest way is in Python is basically to loop through elements, which in this example happens to be elements of a list. So we can say for score in scores, print score. The key thing parts I want you to notice here is the for keyword, in, and scores. This is something you want to be iterating through. It has all the elements we want. And there is a new thing here which I called score. So I'm saying for score in scores. Now notice that if I'm going through all the elements in scores, I want to do something for every element. Now to be able to do something on every element, I need to temporarily remember that element which I'm currently at. And that's why I'm currently calling it score. I can call it X, I can call it number, I can call it student, I can call it anything. The most important thing is I will assign it to a temporal variable, which I call score here, and then inside this whole block, I will be using that temporal variable score to do the things I want to do on this score. Now in this particular example, all I wanted to do was to display score on the screen, and that's what I did. So you notice that it has went ahead and printed all these scores, each one on its lines, with just these 2 lines of code. So as you saw, the syntax is the for keyword followed by a variable name, which you choose for yourself, and then you will go ahead and do nothing. But now, that was one way to write the for loop in Python. Basically, for some variable in something which can be iterated through, and then you will do something. Now, a second way you could find yourself using a for loop is iterating through a range. So we need to talk about a range in Python. As you know, a range is an interval that begins from somewhere and ends somewhere, or possibly doesn't end. Yeah, but in Python, or in other programming languages, basically. But specifically in Python, we have this built-in range method, which we give it the starting point and the ending point, and the step, which is like how much do you want to be incrementing, and then it will give us that whole range. Take this example. When I said for I in range 1, 10, 2, technically what I meant was counting from 1 up to just before 10, incrementing by 2. So that range is what I got here. I counted from 1 and I'm incrementing by 2. So the next is 3, next is 5, next is 7, next is 9. Notice that if I try to add 2, I'm already past 10, which is not allowed. So this is the range we got from that statement. Now, notice that if I can find a range like this, then I can iterate through this range to get those actual numbers. That's why I said for I in range 1 to 10 incrementing by 2, print I. So every number I pass by as I go through this range, I will print it, and this is what happened. Now, knowing this idea of the range, you can ask yourself, now what happens if out of those three arguments, what if I give just one? Or what if I give just two? What happens? So it turns out if you give just two arguments, if for example I only gave 1 10, Python will assume that you want to count from 1 to 10, and for the third argument which is missing, it will by default consider it to be 1. So it will give you 1, 2, 3, 4, 5, 6, 7, 8, 9, and that will be what you get. Now if you only give it one argument, like in this case, it will consider it to be this ending point, and it will take the starting point by default to be 0 and the step to be 1. Now if it does that, you see for x in range 8, we will end up getting 0, 1, 2, 3, 4, 5, 6, and 7. And we stop just before reaching 8. I will take some water. Notice that it started from 0 and the step was 1 by default. Now, a third way to use a for loop, which is rather more common, and I think it's more like hybrid of those two methods, is now to actually loop through the array at normal, but using the index. Now, for example, suppose you wanted to change every element in this index. And one thing we saw is that we can grab that element by specifying its index, and then we can assign it to a new value. Now, one way we can do that is, if we have a list of elements like this, if we could know its range, then we can iterate through the range of which is the range equal to that length. And every number we pass by will actually be an index which corresponds to a certain location inside the score. For example, this score has a length of 1, 2, 3, 4, 5, 6, 7. So if I obtain a range of 0 to 7, which means 0, 1, 3, 4, 1, 2, 3, 4, 5, 6, then each of those indexes will be representing a certain element. This will be at position 0, 1, 2, 3, 4, 5, 6. So actually, if I iterate through the range of n which was 7, every I which I'm passing at is corresponding to a valid index in my scores. So I can actually go ahead and print scores I. So this is the element in scores at index I. Now I really encourage that you pause at this point and practice this syntax until you understand it. It's a for loop which goes through the range of n, where n is the length of the scores, and we'll be grabbing elements at position I as we go. So when I was 0, we grabbed 60, which is at position 0. When I was 1, we grabbed 74, and so on until we finished. Now, the next topic is the while loop. Now, the idea of the while loop is really expressed in summary in this example I gave here. So at the moment of recording this video, we have the coronavirus going on around everywhere. I'm currently in South Korea, and although the situation is not too bad here, but it has been bad for some days in the past. But yeah, so everyone is wearing masks, everyone is being advised to stay at home. So you can imagine that the instruction will come sounding like, while coronavirus is still a big issue, stay home, wear masks, social distance, and so on. And once we have the vaccine or we have immunity, or I don't know, if it's no longer a big issue, then we can resume unnecessary travels and we can resume parties and everything. So this is that kind of instruction is a perfect use case for the while loop. You want to do something for as long as a condition is still valid. In this case, as long as coronavirus is still an issue, we will do all these things inside the loop. And once this condition is no longer satisfied, then we will break out of the while loop and emerge from this block to outside the block, which will bring us back here, I trust. We resume the party and we resume an start traffic. So the keyword is while. You write your condition, colons as normal. You start a new block. You write all the logic you want to be implemented as long as the condition is true. And this logic will be implemented over and over again until this condition you mentioned here is broken. Then you will break out of the while loop. A quick example here. Now, we have two ways to break out of a while loop. One way is to specify the breaking condition at the same time when you are initializing your while loop. So here I said, while a is less than 5, then I want to be doing these things. So this means if my a is no longer less than 5, then this while loop will be terminated. Notice that when I say while a is less than 5, and remember I start with a equal to 0, if I don't include this line where I increment a by 1, and if a is forever 0, then this while loop will be executed forever. So that's why I call this method, it's kind of converging towards, it's merging, or I don't know, towards the breaking condition. So we set a breaking condition and we try to come towards it. So the breaking condition is a is less than 5. So we want to be approaching a situation where a will be no longer less than 5. That's why I'm incrementing a by 1. So notice that this while loop we iterate around 4 or 5 times, I guess. And once a is no longer less than 5, we just break from this while loop. A second way to do it is to start your while loop with no terminating condition. You can say while true. That's a very common way to start a loop without assigning any condition. And then you can write all your logic inside, and you can set your custom breaking condition inside the while loop using if statement and break keyword. Basically what this does is, I said here, for example, in this example I had a secret number and I want to create a program that asks a user to guess the secret number, and I want them to keep guessing until they get it right. So I have my secret number and I ask a user to enter a number, and I say if my guess, which the user just gave me, is equal to secret, then break. This break, what it will does, it will break the while loop which is closest to it in indentation if. You notice that you can also break from the for loop, actually, didn't mention it. Yeah. So basically, if you guess and your guess is not equal to secret, then you will not break from the while loop. Instead, you will run it again and again and again and again and again and again. This will be repeating itself over and over until you guess it right. Now, I mentioned about the possibility of having loops that never stop, and that's a famous case known as infinite loops. The infinite loop never ends and it never breaks. Whatever is inside it will get executed forever. Well, not really forever, since your computer will run out of memory at some point, or it will run out of power, or you will run out of patience and shut it down forcefully. Yeah, but it's supposed to run forever. Yes. The reason why that happens is because you wrote a code that does not specify any exit condition for the while loop. For example, look at this, is a very classic example for loop 2. I have a which is equal to 10, and somehow I say, okay, as long as a is bigger than 0, print a. Notice that a will always be bigger than 0 because I'm not changing its value anyway, and a is 10. So a will always be bigger than 0, so I will print a forever. You can try this in your computer, and you will notice that it will keep printing a forever until you run out of patience and just hit Ctrl C to terminate the program. This is basically a shortcut you can always use if you have a program which is taking too long and you are scared for your computer, or you have other things to be working on. So the third loop is 1 plus 1 equal to 2 as long as this condition is true. Notice that this is true for as long as I have been studying, or I've been intelligent, if I should say. 1 plus 1 has always been equal to 2. So this is a valid condition always that you keep printing. The same goes for while true. While true is also a statement which is always true. So infinite loop never ends. Hit Ctrl C to stop it. Now we get to the third topic of today, which is really important, and it's functions. If you have studied some algebra or some basic math in your old days, You know that we used to have something like f of x, which would like receive x and it would give us some value. So a function basically takes something and gives something else. So in programming, it's not that different, except that the functions we write in programming are much more powerful than the ones we used to write on our books and our papers and our math homeworks. Functions in programming, they are block of code, which when they are called, they execute, they perform a certain task and they return something. That's basically what the functions are in programming. So the motivation is that we write that piece of logic once and we can run it anytime we need it. And that's really the core motivation behind using these functions. Now functions are very helpful because you will notice that without functions you would need to be writing so many lines of code on the top of each other, and really every time you need to reuse the piece of code you need to copy it and paste it again, and that's really a bad practice in programming. Now, how do we actually define functions in Python? The syntax for Python functions is the def keyword, which is defined in short. Now after the def keyword, what you add is the name of your function, and I will tell you about the best practices to name functions. After specifying the name for your function, now in your parentheses, you specify the so-called arguments which the function receives. So what does the function receive? Because it has to work with something in most cases. And then the colon, of course, and you hit enter, you start a new block with indentation. This is what I'm calling indentation, by the way, if you happen to not understand. This empty space which we are leaving as we start a new block. Now this particular function, all it does is to add two numbers. So it receives x and y, and it return. This is a very new keyword. So return is basically what it says. What does this function return when we call it? So it returns x plus y. It receives two things, it returns its sum. That's basically the logic of a function. Now, one thing to notice is that functions does not get executed as soon as we write them or as soon as the CPU reach them when it's reading the program. Instead, after defining a function, we need to call it to actually use it, because you remember we saw that we can use it many times. So we define it, we put it there, and whenever we need it, we call it and it does the job and we continue. So calling a function is also known as invoking a function. So I defined my function here, add, which takes two numbers x and y and returns their sum. Now I need to use it. I will call add brackets and I press the actual values which I want to pass into my function. So the first value I pass 100 will come in as x, and the second value will jump in here as y, and I will return 100 plus 100, which is 400. Now if I want to reuse this output of this function, then I better save this output to a new variable which I call sum1. Sum1 is equal to call a function, pass in the arguments, its output will be saved to this variable. Now in the same way, I could also reuse that piece of logic by calling it whenever I need it, passing in different arguments, and it will always work as it is expected to do. So this is a really shows you how functions are really powerful and so important in programming, because if I'm writing a program which has 500 lines of code and I have defined this function on the first and second lines of code, if I'm at line 300, I can still call that function and use it. So you can always access your functions, and this is really cool. Now, a few good practices though to name your function. It's always a good idea to give your functions meaningful names. You don't want to be calling your function f or x or y, because if someone reads that function, they will have no idea what it does. So it's always good to give it a name which explains what the function actually does. If I call the function multiply and you read this name, you will have an idea of what it does. If I call it find cheapest freight, This is such a good name because when you read it, you understand what the function does even before reading the code inside it. A second good practice is to use the Chemo case. Chemo case is basically using the capital letter for every word except the first word. Remember that when we were learning how to name the variables, we were using underscore to separate the words. Now in function names, we use capital letters if you want to use a name which has what would be more than one word. So capital letters except the first word. Why don't we also use capital letter for the first word? Later we will see that that's what we do for what is known as classes, which is what we see in the later parts of this course. Now, Chemo case, capital letter for every word except the first one. Python functions are also very powerful. They can return almost anything, integers, floats, strings, list. And because Python is such a dynamically typed language, we don't need to specify what type of data our functions will return when we make them. In other languages like Java or C++, you need actually to say, okay, this function will return integer. This function will always return a string, something like that. In Python, you just go, you write your function, and you're good to go. Okay. I also mentioned that the function, you need to remember the order in which you're passing your arguments, because if I'm passing in two arguments, the first one should always be the first value which I'm passing in. Just don't mess up. And if you, for example, wanted to, maybe say you wanted to find the difference, and you say return x minus y, make sure the first number is the one you want to be x and the second one is the one you want to be y. Okay. Another idea is the default values. So the default values is you have a function which is supposed to receive a certain argument, but you want to define what your function does in the situations where it might be called without receiving any argument. So a default value is what it will use if it's not given any argument. Take this function for example, it's called findAge, again a good name. It receives the year in which a person was born, and it returns their age by taking the current year, 2020, minus that year they gave us. Now, if you don't put in anything, it will by default assume the year to be 2020, and it will return 2020 minus 2020, which will be 0. On the contrary, that's the case which we have here. If you do put in the year argument, then it will calculate, it will use it and give you the answer which you want. So if we give in a argument, it will be used. If you don't give it, the default one will be used. And to use it, just add equal sign 2020, put in a default value you want. And now we actually, I have a few examples here to help you as you learn. These are a few exercises which I put in three categories, ones which are quite easy, ones which are slightly more interesting, one that could be a little bit more challenging, and I have solved them for your benefit. And at the end of this week, I will actually have a few exercises for you to practice which are not solved. And because this video has already been long enough, I will not be able to go through these examples, but basically these are functions, all of them. I think I can actually talk about a few of them. So this was to write a function that receives my age and it returns my birth year. I called it born when, again a good name. It receives age and it returns 2020 minus age, and you can invoke it, save its output to a variable, and you can print that variable to see the output. This is the second one is quite easy. The third one, we wanted to write a function that receives two numbers and it returns the smallest of them. So I called it find smallest. It receives num1, num2, num3, and it returns the minimum of those three. This is a built-in Python method called minima, which is really cool because it gives us the minimum of the elements we pass in. So I pass in these three numbers, it gives me the minimum, I return it. Now I can always call find smallest and pass in some random three numbers, and it will always give me the answer. For this category, I think the interesting question is this third one. which is where we are basically counting the occurrences of A's. So suppose we had a string which had like so many words and want to count how many times alphabet A has appeared, both uppercase and lowercase. And you can actually tweak this function to work for other alphabets as well, or the whole words, the actual words. So the idea is to start a counter at 0 and increment it every time you meet A. And at the end, you just return how much your counter has found so far. So I launch my counter at 0, and then I loop through for every character in S, which is the string I received. If the character is the capital A or small a, I will increase my counter, and at the end I will return counter. Now, go ahead and see if you can understand these ones. They're also not too difficult, but they may require some time to understand them. Yeah, but this should do it for this week. I will try to keep the video this much, and then I hope you enjoyed this video, and I hope you found it helpful. And if you did find it helpful, let your friends know who wants to learn programming, and I'm actually giving this content for free to help someone here who wants to learn something, because this is, I believe, this programming skills and Python in particular is going to be extremely valuable in your time. And so if you did have a friend who is even slightly interested in programming, this is the right time to learn. And I would, yeah, you really owe it to them, to share with them this content. And I hope to see you in the next one. So thank you, and yeah, enjoy coding.